All right, let's get right into it. Today, we're going to talk about something that's absolutely critical if you're shipping code on Google Cloud, and that is securing your CI/CD pipeline from the moment you write a line of code to the second it goes live.
I want you to just think about that for a second. That automated pipeline you built for speed, for efficiency, what if that very same speed became your biggest weakness? That's the tightrope we're walking, and it's the core challenge we're going to unpack right now.
So let's start with the big question. Why on earth is a CI/CD pipeline such a juicy target for attackers?
This right here, this is the nightmare scenario. We're not just talking about someone stealing a bit of data. We're talking about an attacker getting the literal keys to the kingdom. They could use your trusted, automated systems to push their malicious code, their backdoors, straight into your live apps. It is the ultimate Trojan horse.
So how do we stop that nightmare from ever happening? Well, we have to do what's called shifting left. All that means is we build security into the process from the very, very beginning, long before anything ever gets close to a production server. What we need to do is create this gauntlet of automated checks. So first up, you've got Static Application Security Testing, or SAST. This looks at your raw source code for common bugs. Then, and this is a big one, we scan all the third-party libraries you're pulling in, because that's where a ton of vulnerabilities hide. And finally, after you've packaged all that up into a container, that image gets scanned the second it lands in Google's artifact registry. It's like a 3-stage security checkpoint before your code even gets a chance to run. Okay, so you've done all this scanning, but how do you actually enforce that only the clean, verified stuff makes it through? Let's talk about the ultimate gatekeeper, binary authorization. Think of binary authorization as the bouncer at the front door of your production club. It doesn't care how an image showed up. If its name isn't on the list, if it hasn't been properly vetted and signed, it is not getting in. End of story. It's a hard and fast security check right at the moment of deployment.
So how does this whole thing work? Well, it all starts with a policy. That's just your rulebook. Then you have an attestor. Think of this as a trusted authority, like your security scanner that vouches for an image. And how does it vouch? By creating an attestation, which is basically a digital signature that says, yep, I've checked this and it's good to go. And, for those real, true emergencies, there's a logged break glass option, a way to manually override the system when you absolutely have to.
Let's walk through the flow. Your build system pushes an image. The scan runs. If everything looks good, an attester automatically signs it. Much later, when you try to deploy that image, binary authorization steps in and says, hold on, show me your signature. If there's no valid signature, access is denied. Simple, powerful, and incredibly effective. And hey, here's a little pro tip for anyone studying for Google Cloud Cert. If you see a question and it's asking about enforcing approvals or making sure only vetted images are deployed, your brain should light up with binary authorization. It's a classic for a reason. Okay, great. We've secured the code itself. But what about all the sensitive stuff the code needs to run? The API keys, the database passwords. Let's talk about secrets. This should be rule number 1, tattooed on the inside of every developer's eyelids. You never, ever, ever commit secrets into your source code. It is the first place attackers will look. Instead, you need a dedicated, secure vault. And on GCP, that's called Secret Manager. Now, you're going to need secrets at 2 different times. Sometimes at build time. The build process itself needs a credential, maybe to pull from a private repository. But way more often, your application needs secrets at runtime, when it's live and needs to talk to a database. That's when the app itself should securely fetch what it needs from Secret Manager right after it starts up. 2 different moments, 2 different approaches. Oh, and here's another killer exam tip for you. You'd think you could set up automatic secret rotation from that nice, friendly web console, right? Nope, wrong. You can only do it using the G-Cloud command line tool or the API. This is a classic trick question, and it's designed to trip up people who haven't actually had to do it in the real world. So don't forget that one. So our code is scanned, our deployment is gated, our secrets are locked in a vault. We're done, right? Not so fast. We still have to protect the application while it's actually running and facing the internet. I absolutely love this analogy. Think of Web Security Scanner as your internal inspector. It's what we call a dynamic testing tool, or DAST, and it actively crawls and pokes at your live application, trying to find weaknesses. Cloud Armor, on the other hand, is the external bodyguard. It's a web application firewall that stands out in front, blocking nasty traffic like DDoS attacks or SQL injection before it ever gets close to your app.
One finds problems, the other protects you from them.
And just to really hammer this point home, let's be crystal clear. SAST, the static scanning we talked about first, it looks at your source code before it's even built. DAST, like the web security scanner, tests the real, live, running application after it's deployed. They're two totally different tools for two totally different parts of the process.
Okay, let's pull all these pieces together. See, none of these tools is a silver bullet on its own. They're designed to work together to form a complete end-to-end security chain that protects your code through its entire lifecycle.
So if you take away one thing, let it be this checklist. Scan everything. Gate your production environment with binary authorization, vaults your secrets, and remember that little trick about rotating them. Test your live apps with a DAST tool, defend them with a WAF like Cloud Armor, and wrapping around all of this, always use the principle of least privilege for your service accounts.
And that brings us to the final thought. Look, putting all these tools in place is a huge step forward. But even the best technology in the world can't protect you from a culture that doesn't make security everyone's job. The tools are only half the battle. Building a team that truly owns security, well, that's the other half. Something to think about.
We hope you enjoyed this video. Like and subscribe for more Apex Insights.